from CyberLink. Today we will present you a webinar about our partnership with Intel for our FaceMe technology. I'm Richard Carrière, I'm SVP and General Manager. I will first do a presentation about the different dimensions of this partnership. It will be followed by a demonstration.
Hello, my name is Craig Campbell, Manager for Sales Engineering at CyberLink. And today, I will be showing you a demo of our FaceMe SDK and how we have optimized it for Intel technology and hardware.
What is CyberLink FaceMe? It is the world's top cross-platform AI facial recognition engine. It offers 99.7% accuracy rate, placing it among the most precise algorithms in the world. It is optimized for edge computing and it runs cross-platform, so on Windows, several versions of Linux, iOS, and Android. Makes it really unique in that sense that no other solution performs as well in each of these three dimensions. In fact, when we talk about optimization for edge computing, we even have different models. We have some three models at the moment optimized for low power CPU, for performance CPU, but also for discrete graphics and VPUs. FaceMe does four things essentially. If you start from the top left, it does face detection. So detect, is there a face or are there faces? How many faces in front of a camera? Recognize faces, so measures vectors on the face that can be matched to a database to identify someone. To the bottom right, it can identify face attributes, so gender, age, mood, and it can also identify face landmarks. Today we're going to talk about three areas where our partnership with Intel is really increasing the performance of FaceMe. One is OpenVINO. With OpenVINO, we are able to grow about 5 times the performance of facial recognition through FaceMe. Intel Movidius can accelerate up to 17.4 times the speed in the case of IoT devices running low power CPUs. And also the RealSense 3D cameras can literally prevent 100% of spoofing attempts. FaceMe with Intel OpenVINO. As I mentioned, acceleration is about 5 times, and this is thanks to a very close partnership we've had with Intel's IoT Solutions Alliance, where we have been optimizing OpenVINO through all our models and platforms. So for example, a processing that would be able to extract data on 4.5 frames per second with OpenVINO increases about 5 times to 23 frames per second. And this is true over every configuration. So if you look at different resolutions here, under Intel i7 7700K, with or without OpenVINO, you see the magnification is constantly around 5 times better, no matter what is the resolution. Even when an Intel Celeron chip, performance roughly doubles. There's other benefits to OpenVINO. One is around the library size. So when we generate a model for facial recognition, the library that comes out from the inference engine can be roughly about 10% of the size when using OpenVINO on Intel x64 CPU with Movidius versus, let's say, an NVIDIA CPU. Some use cases for OpenVINO is basically all about speed. So being able to create a fast, precise experience. So one of them is smart kiosks. Imagine you go to a fast food restaurant or to a store, sign up at a hospital. You're somebody you want to be recognized quickly. You want to have your offers quickly. You don't want any lag. So this is where the use of OpenVINO is very helpful. Another use case is medicine cabinet access with facial recognition. So we've deployed FaceMe in context of healthcare, where frictionless authentication and contactless authentication is quite important. And again, you don't want any lag. You want this thing to perform instantly. So the addition of OpenVINO optimization really makes it a compelling use case. Let's talk about FaceMe with Intel Movidius. This is a case where integrating Movidius into IoT devices can really make facial recognition an efficient and fast solution. So an example of hardware optimization with Movidius is in the case of, for example, digital signage. So we can run the model in small devices with Celeron CPU, and adding the Movidius VPU increases, based on our benchmark, about 17 times the speed, and also reduces about 72% the CPU usage. And this is true whether you use one of Intel neural compute sticks with Movidius, whether you are built-in industrial PCs like Advantech, which has launched a digital signage device that includes Movidius and FaceMe, or even better, we have a partnership also with IEI, where we can have a Movidius card with 4 VPUs that shows amazing performance increase. Give you an idea, if you look at typical Intel CPU versus a Celeron versus a Movidius VPU, the process time to do facial extraction recognition can go down about 90%, 80% from 4,000 milliseconds to 234 milliseconds. And the CPU usage, which would be on a Celeron close to 100%, goes down to about 25%. This is using an Advantech industrial PC. Now, if we use an IEI Mustang that has 4, maybe even 8 Movidius VPUs, then look at the process time. It goes down from 415 milliseconds all the way to 69 milliseconds in some cases. So this is a significant improvement, and again, in a context of an IoT device that doesn't have high-powered infrastructure. Use cases where it is relevant for IoT and where you have typically low-power CPUs is, for example, surveillance cameras. So it's a case where using Movidius can really decentralize, reduce the cost of a structure where you would have multiple cameras while providing instantaneous data collection, such as visitor statistics collected through IP cams. Digital signage is another one. The digital signs, in order to be affordable, typically come with very small powered processing devices. So this is where having Movidius can create a very affordable solution to have fast, compelling digital signs that can be personalized based on who is looking at the sign, can also collect statistics, and can integrate into a CRM system. Let's now talk about FaceMe with Intel RealSense. So this is the anti-spoofing solution. So we have worked pretty close to Intel from the beginning with RealSense cameras. And we're very proud to say that the true positive rate, so the rate to correctly let a real person pass, is 98.2%. So it's very rare that somebody has to do a second attempt. But what's even better is the true negative rate, which means that 100% of the time we would detect a spoofing attack. So this is very high performance. It's very helpful in a context of authentication, where it's either to protect access or, again, to protect signature. Good example also is banking. So either as a secondary method of authentication or even as a replacement to a PIN or to a card, using facial recognition with 3D anti-spoofing of a RealSense camera makes the use case extremely compelling. So when we bring it all together, there's lots of benefits of partnering with Intel. The OpenVINO optimization provides performance enhancements across the board in every use cases, every configuration. Movidius is a very polyvalent solution that opens the door to several low-cost IoT and AIoT use cases that would not be otherwise possible. The RealSense technology adds high-performing 3D anti-spoofing capabilities that can be critical for authentication, for security purposes. And when we bring it all together, all we can say is that our partnership with Intel brings down the barriers to a wide adoption of edge-based AI facial recognition solutions, and it will contribute to a much faster deployment in the market. Thanks. With that, I'll pass it on to Craig, who will do a demo.
Thank you, Richard. Now that everyone has seen how CyberLink has optimized our FaceMe SDK for Intel technology, let me show you some of that in operation. Here you can see our FaceMe SDK running on a Windows system. I'm actually running with an Intel 8th generation i7. So you can see right now it's detecting my face. You can see in the bottom right it does face detection, it's doing face extraction every 9 milliseconds, and face matching. So we're using our very high precision model for IDing me. You can see it has identified me as Craig Campbell from CyberLink, male, neutral, and 22 visits. Down the bottom here, you can see Task Manager. You can see how much CPU we're using. Currently it's 37 to 40. When I cover the camera, and now we're just running the application, and it's not doing any face detection right now, we're using 27% of the CPU to 30%. As soon as I uncover it, you can see it jumps up. Not a great deal. So we're not using a lot of the CPU. The reason being is we're leveraging Intel's technology, the OpenVINO technology that's built into the Intel i7 8th generation Intel chip. So now that we're leveraging that, we're actually using less of the CPU so you can run applications like the one we have here. So let's bring that down a little bit more, meaning right now I'm using 5 threads. I don't need 5 threads for this application, definitely not for our SDK. So let me go ahead and apply a single thread now. You can see that our CPU usage has dropped. Now we're doing 22%. And it's still tracking me, identifying me, number of visits, no problem at all. Okay, let's take this to the next level. Next, I'm going to use Intel's Neural CompuStick number 2. So now we're going to go from OpenVINO, and we're going to use Intel's VPU, Movidius. So I'm going to go ahead and plug this in to my computer, the USB port. I'm going to enable Movidius. So now I want to run off of that directly for my ID extraction and identification. So you can see now our CPU usage is dropping from 20 to 10%, 9%, but we're still tracking, we're still identifying Craig, we're still identifying how many visits, no problem at all. Let's ramp it up one more time. So right now we're just doing one person detection. What about multiple people? Well, let's add a video file here. These people are in my database. So it will analyze them and give them age, emotion, and of course, duration. All this is going to be running from the Intel VPU stick. Here you can see everyone coming through quickly and easily, right from the VPU stick. Not only is it running, it's running smoothly. You can see how quickly everyone is detected on here. If I do a frame by frame operation, you can see quickly how everyone is identified with no problem at all. 11 visits, 34 minutes, 10 visits, 1.3 minutes, female, happy, no problem. Let's change this to the next level again. So you've seen it on a single VPU. Now, let's see how this works on multiple VPUs. Here you have the Intel Mustang V100 with 8 VPUs. And here you see our FaceMe SDK running on a system with that Mustang card. You can see we're running with 4 channels simultaneously, and it's tracking everyone quickly and easily. So you can easily enhance any system with this Intel card. And it's only using 27 to 30% of the CPU running these 4 channels. And now for my final demo, I'm going to show you how our FaceMe SDK is optimized for Intel's 3D camera. Here you can see down below, I am currently connected to the Intel RealSense 3D camera depth camera 435. If I go into here under preferences, I can enable anti-spoofing. I'll turn on 3D depth camera and hit apply, and as soon as I do, you can see I'm now detected as a real person. So now, no matter where I go, it can tell my nose is further than my cheeks, so I am not a photo or a video. If I were to bring one in, No matter what angle we go at, it's going to tell me it's spoofing. So there you go. Photo versus real life. Instantaneous, just walk in and we can check that you are a real person versus someone trying to fake as being you. Thank you. And Richard, back to you.
Thanks, Craig, for your demo. Thanks, everyone, for your attention. For more details, please visit cyberlink.com/FaceMe or contact us at faceme-sales@cyberlink.com.